This is Dr. Meena Sahay, retired professor of physics, Ranchi Women's College, and now attached with Ram Lakhan Singh Yadav College. This lecture is for physics honors students of semester 6 in statistical mechanics. Today we will learn about white dwarf stars. A white dwarf is what stars like the sun become after they have exhausted their nuclear fuel. Near the end of its nuclear burning stage, the type of star expels most of its outer material, creating a planetary nebula. White dwarf stars, so called because of the white color of the first few that were discovered, are characterized by a low luminosity, its mass of the order of that of the sun, and a radius comparable to that of the earth. Because of the large mass and small dimensions, such stars are dense and is compact. They are dense, वो लोग dense भी हैं, and they are compact objects with over average densities approaching 1,000 times that of your water. So this white dwarf stars, unlike most other stars that are supported against their own gravitation by normal gas pressure, white dwarf stars are supported by the degeneracy pressure of the electron gas in their interior. Degeneracy pressure क्या है? Degeneracy pressure is the increased resistance exerted by the electrons composing the gas as a result of stellar contraction. जो contraction होता है उसके कारण. The application of the so-called Fermi-Dirac statistics and of special relativity to the study of the equilibrium structure of white dwarf stars leads to the existence of a mass-radius relationship through which a unique radius is assigned to a white dwarf. माने white dwarf को if given mass को एक particular radius, unique radius assign किया जाता है. The larger the mass, the smaller the radius. Furthermore, the existence of a limiting mass is predicted. हम लोग क्या predict करते हैं? एक limiting mass is predicted, above which, मतलब उस limiting mass above which no stable white dwarf can exist. This limiting mass, known as the Chandrasekhar limit, is of the order of 1.4 solar masses. मतलब मास का एक लिमिट है और उस लिमिट को चंद्रशेखर लिमिट कहा गया है, and that is of the order of 1.4 solar masses. Both predictions are in excellent agreement with observation of white dwarf stars. The central region of a typical white dwarf star is composed of a mixture of carbon and oxygen. उसके बीच में क्या है? Carbon and oxygen compound. Surrounding this core is a thin envelope of helium. उसको surround करता है helium. And in most cases, an even thinner layer of hydrogen. तो बीच में आपका carbon oxygen है, उसके ऊपर में helium है, and then a very very thin layer of hydrogen. A very few white dwarf stars are surrounded by a thin carbon envelope. किसी किसी में thin carbon envelope भी पाया जाता है. Only the outermost stellar layers are accessible to astronomical observations. White dwarfs evolve from stars in an initial mass of up to 3 or 4 solar masses, or even possibly higher. After quiescent phases of hydrogen and helium burning in its core, separated by a first red giant phase, the star becomes a red giant for a second time. Near the end of the second red giant phase, the star loses its extended envelope in a catastrophe event, leaving behind a dense, hot, and luminous core surrounded by a glowing spherical shell. This is the planetary nebula phase. During the entire course of its evolution, which typically takes several billion years, the star will lose a major fraction of its original mass through stellar winds in the giant phases and through its ejected envelope. The hot planetary nebula nucleus left behind has a mass of 0.5 to 1 solar mass and will eventually cool down to become a white dwarf. While dwarfs have exhausted all the nuclear fuel and so have no residual nuclear energy sources, their compact structure also prevents further gravitational contraction. The energy radiated away into the interstellar medium is thus provided by the residual thermal energy of the non-degenerate ions composing its core. That energy slowly diffuses outward through the insulating stellar envelope, and the white dwarf slowly cools down. Following the complete exhaustion of this reservoir of thermal energy, a process that takes several additional million years, the white dwarf stops radiating and has by then reached the final stage of its evolution and becomes a cold and inert stellar remnant. Such an object is sometimes called a black dwarf. तो हम लोग ने देखा कि पहले ये वाइट ड्वार्फ बनता है और फिर उसकी रेडिएशन होते होते बिलियन ईयर्स में इट बिकम्स एन इनर्ट फॉर्म एंड बिकम्स अ ब्लैक ड्वार्फ. थैंक यू.